Hey everybody, this is Larry, this is me going with Q4 of the weekly contest 307, find the case sum of an array. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. So this problem apparently was on an OA of Amazon, and apparently, you let me know if this is right. A lot of people Googled it and solved it during the contest. I wasn't able to solve it. It was a very hard problem. I was very close in a couple of techniques, but I ultimately just didn't get it. So I'm going to show you the way that if you had Googled, you would have gotten. And for me, I was actually happy about this contest. The contest was actually challenging instead of just typing, so I'm happy about that. And I did learn a little bit of a technique here with respect to the idea about brute forcing in a smart way. I think this is just about, it's kind of like that. It's kind of like, the inclusion type thing with depth first search. This is except for using heap, and this is basically the idea, right? There's a couple of observations, and you can watch me solve a live in the contest next. But the observation here is basically try to figure out how to pigeonhole your way into this K. K can be at most 2,000. So that is the key thing that we're trying to figure out how to optimize for. And yeah. And basically the idea here is that, okay, so what is the biggest number that you can get, right? The observation number one. What is the biggest numbers that you can get? Well, the biggest number you can get is just sum up all the non-zero all the non-negative numbers. So basically you take all the number, you add up all the non-negative one, and then that's your max number, right? So that's going to be your K is equal to 0 or K is equal to 1 because K is 1 indexed or whatever. But yeah, so that's basically the idea, and you could kind of see me doing here. And then the second part then now is that this is the total, right? This is the total, that's the max possible number. And then the second part is that every number after, so you can only, so this is the biggest number, so the obvious thing is that every number you subtract is going to be, a smaller number. And that's basically the basis, is that if you take away some of the components, so there are only two ways now, right? One is that we add in the negative numbers, which will make the number smaller, obviously, or we remove a positive number from the already added set, which will also make the number smaller. And also there's some stuff about handling zeros, but in the general case, it should be okay. Yeah, so and that's basically what I have here. I kind of and here the idea is also greedy in a way, right? Where we basically try to figure out the smallest contribution, right? Because in both cases, in both positive numbers and the negative numbers and 0, I suppose, you are subtracting from it, even though they have different signs because of how you construct it. And of course, in a greedy kind of way, you want to subtract the smallest number to keep on getting the biggest number. That's the repeated part that we're talking about, and that's basically the way that we have here. Yeah, and this is the key part, and this part is a little bit tricky, so bear with me. This is the first time I've seen it. I think I have an understanding of it, but if I'm, a little bit unclear, leave a comment, ask specific questions in here or the Discord or whatever, and I'll try my best, because like I said, this is my first time explaining it, so maybe my understanding is wrong as well. But record that the way that I think about it is that basically, what is the brute force way to do it with recursion, right? So you do some recursion stuff, you maybe do something, and I actually did something similar during the contest. You have something like, let's just say def of just go, we have an index, and then we have some current sum, right? And then if you do something like go index plus 1 current sum increment by num sub I, or num sub index in this case, and then you do it again, but you don't add it to the numbers of index, right? So this is the brute force way of doing it, and of course you have some base case, but you know what I mean. Something with current sum, right? So yeah, like answer data pan or something like this, right? And here, this is brute force, and this is me typing it in like 20 seconds, right? So that's the idea but now we want to do it in a prioritized kind of way, almost like kind of like an A-star search type thing. Instead of doing a recursion distance search, we do like an A-star search kind of thing in a way. Here there is some nuance in how I implement it just to make it a little bit easier. So here we want to, the way that I did it is by, this is the current is equal to the total, the sum of all the negative components, right? So this is for negative numbers, this is added in, and for the positive numbers, this is subtracted from, right? This is the stuff that we talked about. I know I'm repeating it, but just want to focus on getting it right. And then here we know that the smallest, or the smallest sum after the total is going to be the total minus the first sorted absolute value, because that's the smallest negative component. So we subtract that, and then here we have the index. And here, this is the same idea, is that basically, I know this looks a little funky, and like I said, I didn't think about this during the contest, so this is very hard. And even though this is on Amazon, I don't. Sometimes these are things where it is what it is. I don't know. Crazy Indian Chinese always. They're so hard for us Americans. But here the idea, even though this looks a little bit awkward, I think this one makes sense. It's just basically, but you can think about this similar to what we had before, right? Which is that this is just go of index plus 1, current, and that's it, right? We don't add the number here. The idea here is that this means that this current contribution, we subtract it back out, so then we're skipping it, right? Meaning that you can think about it as, if you think about it as a let's say 1, 2, 3, 4, 5, something like this. Here we have 1, right? And so basically in a breadth first search kind of way, or a depth first search kind of way, we want to try all the possibilities, right? Well, what are all the possibilities? There's 2 to the 5th possibilities, every possible like 1, and then the possibilities are 1. Let me write it out in a better way. This is just all the possibilities where you have none of the numbers, that's 1, and then 1, and then 2, and then 1 and 2, and then maybe 3, and then 1, 3, and then now 2, 3 maybe? No, it's 4, and then 2, 3, and then so forth. So that's basically the idea, is that we're trying to do every possible combination. And this is basically what we're doing here in a very prioritized kind of way. This is basically saying, so basically this branches out twice. One is just, all the sums. So now this is, if you're here, then it goes 1 plus 2 plus 3 plus 4 plus 5, ... And then here is just subtracting out the current contribution. So then now the last number doesn't count. It's a very clever trick. I didn't know this tech, or seeing it makes sense, but I don't know. And if you watch me solve it live, I did try to come up with something similar, but I wasn't able to get it precisely right, because I haven't seen it before. But apparently, like I said, but it's very clever, and definitely something that that was the missing piece for me, because I did everything else. You could watch me solve it during the contest, and yeah, even though it was Googleable, a lot of people didn't get it. So I think that this was just a very, very hard problem, and I don't even think that many people Googled. Otherwise, there'll be more solves, I suppose. But I think probably a good amount of people Googled. I don't know what that means, but yeah. So that is it for this explanation. I don't know if this is a great explanation. Like I said, it is a new explanation for me, and I don't know. This is maybe the first time I've used this technique or seen it, to be honest. So I'm learning this technique as well. So I don't know how often this comes up, or because with these problems, with these things, it's easy to not know what you don't know. And what I mean by that is, maybe in the past I could have used this technique to solve a problem, but I just didn't see it or think about it. So for now, I don't know how what my recommendation level for this problem is. But I would also say that, like, in general, unless you're really strong in a lot of other things, it's okay to skip certain things, right? Because you want to be really good on things that you're good about versus being moderate on extra techniques. Because if you only know about this technique and you're still not able to solve a harder version of this problem, then it's wasted time anyway, right? Anyway, one more thing though. One thing that so this one I'm okay with. This idea, this algorithm, I'm okay with not getting, but with some credit to, I did have some credit here, but I did see a sort and merge technique that I should have maybe figured out, and I'm going to live solve for you now. So if you already get it, then fast forward or whatever you need to do. But I'm going to try to live solve this second technique, which is taking advantage of the K, right? So let's do it. Let me think about how to do it. I have an idea, but I don't know how. So let me, or like I don't know the details, because if I know the details, this is just me typing it to you, right? So I think I was just given a little bit of an idea, and basically the idea is brute force. And then this is the same idea, right? So okay, yeah. So then the idea here is try to take advantage of K a little bit more. The idea here is maybe figure out a way to do K squared. And then here it'll be for something like for X in S nums up to K. And here, yeah, I think this is the idea. Basically, the idea is almost very similar to, this idea is basically the same as a similar DP that I was actually thinking about during the contest, but I just couldn't really, I don't know. I think I should have gotten this one if you ask me in this way, but I just, some days, some days are just some days. And the idea here is almost like, and maybe this is something that would occur to you if, in a very elementary way, but I wasn't able to put together. And the way here is by doing, what's it called? Knapsack DP in a way, right? It's not quite the knapsack DP, but it's almost the knapsack brute force DP. I don't know if that means anything to you, because maybe I made those words up, but we'll go over it together. But basically every iteration, we just start with, the current iteration we have 0, and then now for X, we just go, next is equal to X plus, let's say, the previous for previous in current, right? So basically now we just generate all the possibilities, but then here we want to trim it down. Actually, someone just told me about this other thing. Hang on. So that I'm trying to learn how to use as well. Hip Q, where did I have it? But apparently hip Q has a thing that takes sorted lists and then add them in linear time. So let me try to do that. But basically, current is always sorted, or that's an invariant we're going to keep. And here, if current is sorted, this is going to be sorted. So then now we go current is equal to, oh, I guess I had that, but hip Q of current and X. Yeah, right? And then we also just take the first K element, because obviously we have more than K elements, we don't need to care. And that's basically it, really, I think. And then now we just return current sub K, or total minus current sub K. Because again, we want to keep the mins. So yeah, module, oh, what did I do? Whoops, I forgot that merge. Okay, generator not subscriptable. Okay, I mean, we just have to convert it to a list, because we turn the generator. Okay, int and generator. Did I think the syntax always confuses me. I have to do this to convert it explicitly to a list. Okay. Do I have an off by 1? Oh yeah, this is k minus 1 because, yeah, okay. And that's pretty much it, really. So yeah. Unless this times out, that would be funny. I was told that there's this would be k square. Okay, time limits. I saw, not gonna lie, I did thought that I saw this to work. Maybe this is not linear time. Maybe I'm wrong here. But I think this is the way that I thought I saw this and saw it to be right. Huh. That's weird. Actually. Let's see. Does this give me the time? I hope so. Okay, 1 second. Also, this is I guess it's fine. Apparently this times out. Can I do a manual sort merge? But anyway, this is the idea, right? Is that so the idea here is that we want a linear merge of 2 sorted lists. So that's basically the idea. And maybe we can, maybe this is too, no, I mean, because this has at most 4,000 elements, so it should be okay. But yeah, yeah, maybe we have just something like this, and then while length of ends is less than k. Yeah, and then we have, say, IA is equal to 0, IB is equal to 0, and then these are just index. How do I do it? Then we yeah, and then if A sub IA is greater than B sub IB, then we append A sub IA. No, we would do the smaller one, and then else. Oops. Of course, right, and then now we do, this is just regular merge sort stuff. Then yeah. And we want to keep it smaller than I don't know. I was trying something new. I thought that's just linear though, and I would think it's optimized, but apparently maybe not so much. This is only slightly faster, so we'll see. I've seen similar solutions to work, unless I'm missing something weird. And this is a little bit awkward though. This may make a timeout actually. Well, at least it definitely doesn't help. So we'll see. Okay. Let's see if we remove it. Is it faster? Because that just makes an additional copy. This is actually very slow. Is it just like a transient thing? Definitely could have sworn I've seen it, during the contest. Did I miss something weird? Look at the first K. Is that okay? It should be okay. And then merge, right? Yeah. Give it a submit again. Yeah, I don't know. If this doesn't work, I don't know. But this should be k square. Maybe I should do it in another language, but I feel like I definitely have seen. Why am I on second pages? But I feel like I definitely have seen some people doing it this way. And well, this one is that, except for it's even worse. Right? Like, is this not slow enough? I don't know. Because they don't even do the merge. Yeah. Anyway, So this is the idea. Maybe I'll rewrite this in another language. But oh, what the? Oh yeah, this is my whatever earlier. That's really awkward, actually. Don't know why this times out, because this is only k-square, but unless I'm doing something silly. No, it seems like it should be okay. Alright, let's just try it in C++ and then see what happens. Do I even need n? I guess it doesn't matter. Okay, and then now we also want to sorted nums, say. I guess I could just do this. Something like that, and then that's really weird though, because then maybe I wouldn't have gotten this during the contest, but some people got it, so I don't know. I don't know how long this should take, but alright, that's weird, but what I want is 1 0. So basically min of this or k. Then we have current number is, yeah, okay. I need to use iterator more, but j plus s nums of I, and then now we have to merge it, right? So current is equal to merge. I'm a little bit sketchy on the syntax, that's why I'm a little bit awkward. And then k minus 1, or total minus this. But yeah, and then now we can have something like what is my syntax here? And then it's just and then we have something like this. Can I just copy and paste this? Kind of, not really, but I'm a bit lazy, so I'm just gonna edit this. This is probably not not as clever as I thought it would be. Okay, so this is good though. Well. Sorry, I'm not talking much. I mean, this is just me typing right now. I think this is just really, this is basic merge sort stuff. So that's why I'm not really explaining it. There are definitely enough merge sort problems. So definitely if you're struggling with merge sort things, definitely check that out. But I am just, getting some practice in and wondering why this is too slow, to be honest, in Python. And I think I'm also returning by what you might call it, by copy or whatever, by wire, and that's probably a no, but whatever, it should be fine maybe. Let's see how long that takes, or even compiles. Min is not good because one of them is an unsigned. Okay, so is this the same? It is the same. It is a little bit faster, but still pretty low for C++. So let's just give it a submit and see if this works. May still time out, but if it times out, I'm really confused. Did I miss something really obvious? I don't think I'm doing anything that dumb, but all right, let's see. Now I'm in the cheating phase. All right. Did that resize? Oh, did I not resize this? But this should have, like, how is this faster? Oh, there's an in-place merge that also may be helpful. But even without it, I'm kind of confused as to why this isn't fast enough, to be honest. Like, I don't think just converting this to in-place merge is, I don't even know how in-place merge works, but I see how this works, but like, is that fast enough? Anyway, I'm really confused right now, to be honest, because I feel like we basically did the same as here. The idea isn't that hard, but I don't know why we're getting time limit exceeded. So, very confused. Not gonna lie. Can I do anything smarter other than doing the in-place thing? It's very weird. Because this is k square, but maybe there's a bit of a constant. But in how do I return by? Oh, also I messed up here. I should return. Well, I guess auto kind of took care of it. Is that how I do it? I don't. Let me see. C++. Return vector by without copy by reference is what I want, but that makes sense. I can't allocate on a stack. I need to. All right, let me cheat a little bit and do this in-place merge thing, and then see if that's fast enough. I don't. Yeah, I mean, okay, fine. This will be the size. So then, is equal to current dot size. Yeah, okay, and then now we do current, right? And then now we do the weird in-place merge thing. Is that how we do in-place merge? Is that that just feels so weird. Let me look it up real quick. This is the first time I'm using in-place merge as well. So merge two consecutive sorted range into one sorted list. Okay, I guess this is the way to do it. I don't know. I never would have thought to use this, to be honest. But okay, so I imagine something like this. Whoops. And then current dot, oh, no, not current dot end. Current dot begin plus m. Just want to look at the API. So it should be first, middle, last. Okay, so then just current.end maybe. Well, this time limit exceeded anyway for just these three. Really? Man, there's a lot of things funky going on today. Because as you can see, everyone else got it right on this one. So unless I'm really okay, how do I do it? Should be current.end should be okay, right? I mean, I know that I'm not doing it here like this, but maybe that's why you got one wrong answer, is because they did the sorting. But oh, I didn't resize this. This one is my fault. Because on the other merge we do it. Okay, current that resize of yeah, min of current dot size or k. Okay, I did forget about the resizing though, so that's probably why. So that's why it time limits, because now it has like 2 to the n copies. Okay, so that looks good. Well, we're only a little bit faster, maybe like twice as fast or something, but that's not a, like, this doesn't really teach me anything, right? I mean, this is fine, but this doesn't really teach me anything, so that's just a little bit whatever, like, it is what it is. But the idea here should still be that k-square is good enough. I'm really confused as to why or how certain people, like this one, is fast enough, right? Like, let's go. Did it have my thing? Yeah, it did have my thing. So yeah, so this is okay, but if I did it here, this takes 1.1 second, which is already too slow. Is this any faster? Is there anything that I missed about this? Huh, this is much faster. Why is this so much faster than what I have? That is actually crazy. That is twice as fast. Like, would that be? Yeah, why is this so much faster with the sorting than the merge? The merge, is this because I have to allocate space? But we have to allocate space anyway for less than k for here, so I guess sorting is way fast, but how is this faster than mice? This is crazy. I don't know that I believe this, but like, why is this sorting? Let's give it a submit real quick just to see if this is fast enough. Apparently it is. That's crazy. Why is this fast enough? I would have never guessed that, to be honest. Maybe not never, because there's a lot of crazy Leetcode craziness, but it's just still like, it's not something that I would have thought to do during the contest. Even if I've gotten the merge thing, I did k square, and then that's basically it, really. Then I go very sad. Let's see, did I make a mistake? Like, can I do this? Like, why is this so slow? Yeah, why is this 1.5 seconds? Why is the merge slow? Is it because I'm merging one at a time? I mean, I know that there's a lot of optimized things in Python that's written, and maybe that's the way, but that is just like such a crappy thing to do, to be honest, that I'm a little bit saddened about. Maybe there's something about Tim sort. Let's see, derived from merging. Gallop mode, descending runs, merge space overhead. I don't know. In the worst cases, n log n, we knew that. Merge criteria. Well, balance merges. A apparently there's a lot of, so Tim sort, I mean, I actually, I'm not gonna lie, I don't know. Okay, so what I'm doing now is I'm reading up on Tim sort. So Tim sort is the one that's used in Python, and I'm just trying to understand why it is so fast compared. I mean, I knew that if I knew one thing about Tim sort, which is that if an array is approximately sorted, Tim sort is very fast. But I didn't realize that this has this property with respect to. I didn't know that this is a thing. So this is why this is so fast. But and today I learned, to be honest. So yeah, okay, fine. Maybe it's something that I have to file in the back of my mind. But and here you get rid of this code, I suppose. But yeah, that's pretty much all I have for today. That's all I have for right now. Let me know what you think. This is a tiring one. Even knowing the answer, this is a tiring one to solve. Leetcode has ridiculous constants, and this is another instance of that showing that. I don't know. Anyway, but that is all I have though. So you could watch me solve it or struggle a lot during the contest. Now. Come on, no silly mistake. Okay. All right, that was a tough contest. We still have another problem to go, but we're in a good place, maybe. Silly mistake on Q1. Only 7 people got in this one so far. Yikes. Not doing very well, but okay. Choose any, read the problem now. Subsequent some OS elements together. K sum the kth largest subsequence that can be obtained, not necessarily distinct. And K can be up to 2,000, right? So we can maybe do some funky things here. And they don't have to be distinct. 2,000. This is gonna be tough. Wow, I'm gonna need a lot of penalty on this one. Yikes. Okay. Let's sort it first. Largest or big, smallest? I guess it doesn't really matter, but. So the largest initially is gonna be all the positive numbers first. And then I only have to do it 2,000 times. 2,000 times 10 to the 5th is already too slow. Maybe. Is it? Yeah, it is a little bit slow. So basically, the largest will be all the positive numbers, right? And then next, we will either put in a negative number or minus whatever number, minus the smallest number. But then after that, it becomes some crazy 2 to the n thing. But it's only 2,000, so. What is the clean way of doing it? Also, this is a long, right? Like in other languages, it'll be long. So I have to think about that maybe. But because my intuition is some sort of some sort of thing, but so n choose 2, n choose 3. What's n choose 3? I guess 10,000 100,000 choose 2 is already going to be too small. So basically we're saying that oh 2,000. for a big number, it's going to be less than that. We can't even store it very well in a kind of want a buffer search kind of thing, basically. And there's so many edge cases. 4 minutes, really. Okay, so let's say we take because it's 2000, there's going to be basically we want all the numbers minus one of the number, right? That's going to be right except for smaller ends. How do we take care of the smaller ends? I guess that's the thing. Let's see, what is the worst case? Worst case is 2000 square, because then it's missing two numbers. Okay, I think I can manage it. I'm going to use it C++ just because I don't know. We'll see if this works, but just because I don't know, I don't trust Python anymore. So basically it's all the numbers minus one number, but then it could also be minus two numbers, and then subtracting numbers. So I don't think it's just minus one. Well, the zeros is the trickiest part, but that's fine. We can do the math that way. Okay, and then now we want that's actually weird, but I think as long as we get it, it's fine. So we so there's 2 to the zeros possible way of choosing the zeros, right? So if k is less than, so I want something like this, but not really. Let's just say 12, because then 2 to the 12 is 4000, so it should be okay. And then yeah, if k is less than 0, and we just return the sum of all the positive numbers. Oh, this isn't right. What I want is actually this. Then we just return 0, return total. So I want to do k minus minus anyway. And then otherwise, okay, let's say we handle all the zeros. And now we have to remove a real non-zero number. So then we can brute force on the smallest 12 numbers or something. Okay, I think that's right. Actually, I could do this in Python. Now that I think I had a different idea of how to do it, so that's why initially. But yeah. Okay. Right. Okay. And then now we just need to, yeah, the smallest 12 numbers or something. The smallest absolute value, because okay, yeah. Let's just say numbers 2. Is that? Don't remember that's a function. Okay, fine. We want to sort it, and then we take the first. You just say 12 elements. Right. Okay, so this one. Basically, we have 1, 3, 4, and 12, and yeah, okay. I guess it doesn't go out of bounds. So now we want the kth element. So we have a heap. I guess we could just sort it. No need to do whatever. Okay. Index plus 1. Oh, oops. Index is equal to n. Okay. And then now we do away that sort. And then now this is the smallest contribution, so then it will be returned. Something like that. And it's not defined. Two and 11. Okay, so we're close, not quite. I mean, you know, anything could be close, I suppose. But okay, so we have a lot of numbers. It includes 0. So the 0 figures is okay, that's fair. Is 10. Why is that 10? So it's K. K is 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's 10, and total is going to be 20. Wait, what? I think there's a lot of potential mistakes, but I feel like we're right here. We're close, we'll finish. Okay, 20 and 9, so why? We're looking for 14. Why is K 14? Because we did this, and this includes 0. If there's 0 of them, then we subtract. Okay, so I think we want this minus 1, which is none of the zeros. Because that's, yeah. So I guess maybe I just don't need to do it here. Because if there's 1, then we remove 2. Okay, maybe this is right actually. Maybe we did the other thing. Okay, let's see. I don't really have a great examples, to be honest. So, and I don't even have. I don't even know what the right answer should be. So, let's see. This is 6, and then it just goes on for a while. All right, I'm going to YOLO. Mostly because I don't. I mean, I guess I could write a brute force one, but I think I'm okay with YOLOing. Okay. Oh no, this is a not easy to debug answer. How are people doing? Okay, so a lot of people got it, but we still have this maybe. So what is N? Okay, so N is 18. Am I doing this well? So this is the absolute maximum number. We're looking for K is 66, and I assume we have all these. Does this go overboard? Maybe we have some weird issues with me not doing enough numbers. No, that's right, 4,000 numbers. It just prints a lot of it. That's weird then. Am I off by 1? How many zeros is there? There are no zeros, so that's weird, right? Okay, so there's 2 positive numbers. Wait, are there 2 positive numbers? Maybe there are more. I just wasn't paying attention. There are no zeros, so what am I doing wrong? This should really just be right. The answer is 149. It's off by a lot. Pretty huge. Just want to see. So this should be a bigger number. Is that right? Am I off by 1? No, I'm off by more than that. Am I thinking about it wrong? On a different line, but so this all these number. And all these have a negative contribution from the total. So why am I wrong? Tell me why. Like, I don't even know how to be off by that much. Did I not sort it? I do sort it. Huh. Come on, Larry, you're close, I think. It's not even in here, is it? One, 4, 9. It's not even in here. Why is that not even in here? So is this? Yeah, they should be getting. My standard out is weird. Is that right? Did I comment it out? Oh, did it just get dotted? Okay, fine. I was trying to figure out why this was the case, but okay. Okay. It's still not here though. How do I even get this number? 1, 2, 3, 4, 5, 6, 10. Should be here somewhere, right? Huh. It's not even in here. It's not even close. Did I mess up anywhere? Why? Okay. But I returned this, and I don't even see. Oh, I guess I do see it, but that's not the 16th element. What? Oh no, this is not the 16th. This is the 1707. Okay, that's fine, I guess. But why does the other one not even show up if I'm brute forcing this? All right, let me try. Okay, so let's just say I have 20. All right, would that make? That's probably why. Now that I think about it, but yeah. So then now it is in here. So my assumption about using the oh, I see. So using the because it could be a combination of the two smaller numbers that are not being used. That's right. I did forget about this. I was thinking about it, but then I forgot about it. Because it could be the combination of... No, it's just that... Okay, so... It's either these or... I see. I think I got it. It's either this or just missing one of the numbers. So... Yeah, okay. Okay, so it's either the 12th smallest number here or for x in nums, if x is less than 0. Oh, and also there's zeros. I'm missing the 0 case because each of these are zeros as well. Though, I guess in this case, it's kind of factored into here. I think in that case it's fine, actually. I don't know that we need to do here. But, okay, let's remove this actually, just for, because I think there's just more margin for error. Okay, we still have like 40 minutes, so we're fine. Okay, so this is then we want this to append by total minus x, well, plus x, I suppose. Yeah. Because this is generating, and then else, is this gonna be the right answer? Nope, it's a slightly better answer, but still the wrong answer. I have to do 2 numbers inside, is that why? Because it should work, except for this double counts some of the numbers that are already in here. So that's an issue. How do I handle it? But it should still be a bigger number, not a smaller number, so something's still wrong here. And we can make this number bigger, but it still won't fix the fact that we need, let's see. But if you need 2 numbers, are you not already screwed? Okay, let's just do... Okay, and then we can do count or something. just do 3 numbers. And then we can do the brute force here. Sum 2 will brute force on the, let's just say, yeah, 12 is fine. And then we have to brute force the 1 and the 2, so yeah. Something like this, but this is just way easy to be wrong. Oh, oops. That's even a worse answer. Why? Tell me why. You use 1. I don't get it. I mean, I think the idea is right, but I'm just not, getting it right. Well, I think it's something like this, but we convert this to 18, is it right? So 18 we have mostly right, but not really. What? Am I missing a case now? Yeah, I think I'm missing a case. So we take every 2 numbers. So is there a case where 3 numbers is good, but not in the smallest 12 numbers? That's great. I thought there was some pigeonhole principle thing, but which is why I did it this way, but But beyond that, how? I guess if you have enough zeros, no, but because you have 12, right? We have 12 numbers. 12 are the smallest numbers. We don't need to, this is already absoluted, so. I guess maybe this case. Let's just try this for now and then see what happens. Nope, still pretty bad. So the answer is because okay, so let's just say we have this, right? So this now we have it right because now we brute force everything. So that also means that I'm doing it wrong when I have this is greater than 3, so we use 2. This is 1, this is 2, right? So why is this wrong? That's what I want to know. What am I missing from here? This should be this choose 2, and this is all the numbers here. And well, oh, this one overcounts, so maybe that's why, because we already did the one number. I forgot about that one actually. But okay, so we're a little bit closer after removing that. Nope. Why is this off? We chose the 2 number and then we chose the 1 number. Okay, let's put this back in and then we just put. Okay, so then here we do length of R. It should be 496, but it is not, right? Why is that not? Burning a lot of time. 18, so 2 to the 18, right? Okay, so this is actually right in the number. Then why am I not, why is this wrong? Oh, because I'm sorting it by the total. I'm just being dumb. Okay. I am being a dumb. Okay. Okay, now this is right. I am just being a dumb. And then now I could do this maybe? Does this make it a little bit better? Nope. I mean, it's a little bit better, but it's not quite right. Because I don't do the choose 3 part. Maybe I just... $20 is fine, but... even everything less than the number, so I'm kind of worried that... let's see, how many... Okay, so what is 18 choose 2? It's... Okay, 18 choose 3, or 20 choose 3 maybe? It's 20 choose 3. It's 1,000, so 20 choose 2 is 20 choose 3. So 1,000 choose 3 is going to be... Is that going to be good enough? It's because them numbers are actually smaller than this, which is kind of crazy to be honest. But like, how is it that we can generate that many thingies from here? I don't know. Also, a descent is true. Also, even this answer is not true, so I have to be careful and not submit, because I should at least get that answer right. But yeah, now it's bigger, but that's because because this is m's of m, that's why. What we want is for x in R in nums. That's why. Okay. I missed the case for 1 number. Okay, is that right? Nope, still wrong. Why? Why are you wrong? You already have all these numbers. You have every possibility in theory. Why is this wrong? Also, I have this one wrong now, so everything is very wrong. So this is 1, this is 0, 1, 2, right? Why is this wrong? 2, 6, 4. This is also wrong. So something else is wrong here. Huh? I don't know how to solve this, I guess. Why is this wrong? Also, why is this wrong for the input? So together this is 6. 6 minus 5, 0, 1, 2, 3, 4, 5. 6 minus 4 is 2. So why is this so wrong? Did I do the total wrong? I'm so confused. Maybe I won't get it. I thought I could do some sort of pigeonhole, but so okay. So total is 8. Length of the way is 8. Total is 6. That's right. And then so we 0, 1, 2, 3, 4, 5. Oh, it's because I'm don't minus the k minus 1 because we lost the 0 thing that we did before. So okay. Okay, so this is now right again, I think. Yeah, I just set it off by 1. So let's put this back in and then make this again. Okay, this is wrong again now. I don't get how it could be wrong. This is doing the right number, 2 to the 18. Like that should be all the possibilities that lies before us. 0, 1, 2, 0, 1, 2. Yeah, this should be right. Right. Well, this array is negative, so that's just weird. So we want, oh, because this is nums 3, not nums. Okay. A lot of typos here. Okay, so this is right again. But is it right for, if we change this to 12, would that be right? No, right? Even though that is principal here, 16, because we shouldn't need all 18, but yet we do on the brute force. What that means is that 3 of the numbers are kind of putting it in. I guess it is like a thing. Okay. How many people have gotten it so far? I need to change my approach. I think it's more breadth first search. Initially, I thought that it would be this, but yeah. How would I do it with breadth first search? I remove one of the numbers. Okay. Yeah, okay. Maybe we just do something funky. Heap, and then yeah, we do. That's last index, and then that's total. Yeah, okay, fine. And we want a min heap to get the max h, right? So we want the min heap. No, I feel like this is too expensive. What is going on here? Like the way that I'm thinking of doing it. Oh, I guess we could still do it that way. We just look at the smallest 2000 number or something. Because for sure, that should be okay. We want a max heap, so okay. Max. Let's see. So for I index plus 1, index plus k. Right? Maybe that's fine. Because by definition there's some pigeonhole or something, but current is thing. Well, this is this minus. So okay, if is greater than what was that is negative, so okay fine. This is a max heap. No wait, this is a min heap. Yeah, this is a min heap actually. Yeah, okay. Yeah, this basically we want to know if this is if this is greater than this. Well, this is greater than. So now if this is bigger, then we want to append it. No, this is just this. Yep, okay. maybe like while length. Okay, and then we return each of 0, maybe something like that. I should put that code somewhere. This index of, okay, why? Oh. Okay, I did now I can have this. Okay, well, that's unfortunate. Let's see. That's weird. Oh, I guess they should have total on the inside. Okay, 6 and 20 is definitely not right. Okay, so after one iteration is already done because of this. So basically, if this. Okay, 0 and 5. It's a little bit closer maybe, but still not quite right. Here we have 264 as the heap. This queue needs to be a priority queue. That's why. Though it may be just wrong in general, but to be honest. Yeah, okay. This needs to be priority queue. I'm being dumb again. And we want a max heap, so this is going to be yeah, we want a max heap, so we want this, I think. I thought I spent a lot of time on the other one, but okay, so this isn't doing enough work. So there's 1, 2, and 1, 2, and 0. But because it's not doing the 5. I don't know. I thought the pigeonhole would work, but turns out maybe they just quite a small number than I expected. It's actually kind of surprising. Yeah, that's actually surprising. Maybe not, because it could be just a lot of what. No, but wouldn't that really? I don't know how to do this one. I don't know that this is right either. This is my original other code. Can I make this work? Now 15 minutes, I don't know that I can solve this anymore. Oh, I got rid of the other test case. Whoops. Oh well, I mean, it shouldn't matter. Basically, it should already be good enough, right? Why is this wrong? I really should have kept the other case. That sucks though, because I wanted to see. I might have YOLO submitted if I didn't. Well, this one is wrong for this input, so that's just pretty sad too. 6 minus xy. Oh, because of the k minus 1 thing. Okay, let me just YOLO submit. It's gonna be wrong, but okay. Maybe don't print so much, Larry. Oh my, that is just a silly. I mean, it's still gonna be wrong, but that's just a silly wrong answer. I don't know how to do this one. I thought that I could pigeonhole it in, but clearly, it's off by a little bit. Like in this case, because how many choose 3 is good enough? 1000 choose 3 is going to be too big, so just say 100 choose 3. 20 choose 3. 20 choose 3 is already 1000, but then when 30 choose 3 maybe. Alright. 40 choose 4. 20 choose 4. Okay. I mean, why not? What did we say? 100 choose 3. It's gonna be too big, so let's just say 40 choose 3 is 9000. That should be okay, right? Just fine. Now we're just doing more pigeonhole-y. What is this? 51. This is the right answer. Okay, fine. Also, now that other stuff is wrong, so yeah, this other stuff is wrong. I don't know, friends. Oh, no, this is fine, but this is. I mean, in theory, it's fine. It's just that there are other things wrong with this, I suppose. This is 3. I'm just doing a Hail Mary at this point. I don't really know why. Why is this wrong though for this one and this one? 0, 1, 2, 3, right? And 4. I'm looking at for, I guess, this one even. This has 8 numbers, so why is this wrong? we have 6 minus. Why is my answer 4? So k is 5, so we want 2, 3, 4. This is 4, so yeah, 6 minus 4 is 2, right? Do I minus k in 2 sides or something weird? Why does this take so long? Why? Log of k is 2. Oh, why is it 2? Because k is 5. This is so stupid. I'm spending so much time debugging. Really should have this one. But, and this is kind of sad that this might, I thought I know how to do this, but k is 2, why is k 2? Did I just misread the input? K is 5, so then what? Oh, because I'm using k here like an idiot. Okay. Okay. Okay, so this is still wrong, but that's fine at least, maybe. Okay, this is still wrong, but this is fine-ish. So now we want to do no, but then we already do use 3, right? This is very awkward, for sure. Yeah, I don't know how to do this one. I mean, maybe I just thought there's some pigeonhole stuff, but my math is clearly wrong. 30 choose 4. Yeah, I don't know why this is wrong. 40 choose, or 20 choose 5. It's just How is it possible? What is my case? I mean, I guess there is a case, but how is there a number such that the 5 number? I guess they're all ones or something. Like if they're all zeros, for example. But then if they're all zeros, then this should have been taken care of by all these other cases first. Maybe I have to do some deduping. Maybe I have to do some DP. No, I mean, maybe maybe it's just by first search and I'm being dumb. Yikes. And the 5-minute, and I took too long on Q1, but wow, this is just kind of mean at this point, to be honest. If you're a fan, you should get your own handle. It's kind of a little bit harsh at this point. I don't know if that was intentional, but did pretty quickly too. How? I mean, That's really weird. I really thought that that would be enough, though, to be honest, the pigeonhole, but apparently not. I don't know how this is so whatever. Like, isn't there how is it not pigeonhole enough? 5 numbers that are smaller than. I guess you can always construct a case where there's X numbers, so you need a breadth first search. I'm not gonna get a breadth first search in 5 minutes. Hmm. Yeah, I mean, I don't know how to do this one. I mean, maybe it's breadth first search, but I can't even do the breadth first search right. Or, I mean, or at least like the way that I would think about it is through all the. I mean, I think there's a way to do it. I mean, I'm trying to think when I will upsolve afterwards, but. Um. Hmm. It's kind of sad. I mean, it's probably breadth first search, but I just was so stubborn about this one. Okay, let's see if I can upsolve this. I mean, I have 3 minutes left in the contest, so I'm not going to be able to solve this, but I guess that is just how you do it, right? I mean, maybe I just have to. Maybe there is some weirdness here. And then we also have a heap. Total or minus total? It's a max. I always forget. So it's a min heap. We want a min heap. That's fine. And then okay. So then here we go. Just that for I in range of n. If I not in used, then next the cost is going to be the current minus absolute value of s nums of I. If this is equal to 0, or if this is less than target, or h of 0 is greater than next, or the other way around, then we push of h of nx, and then we nx, and then just to set I, right? something like that. And then else, yeah, okay. If is greater than x, then we break. Maybe something like that. I don't know how to queue for. I object is not iterable. What does that mean? Int object not iterable. Yeah, maybe it's trying to sort by this. That's why. That's actually annoying. I don't know how to do it. What a disaster. Oh. Okay. How do I write this in a good way? I'm trying to also cheat a little bit, not gonna lie. How do people get... Okay, so this is basically what I was trying to do, but... Maybe I don't know how to do this though. I don't know that I understand this recurrence. I mean, I guess I'm trying to do it like that, but I just don't know how to do it. I mean, I think I had the idea, but I just couldn't know how. I don't know that I know how to do it. Oh, I guess this is... I mean, this is by first search. It's kind of what I'm doing, but I don't know that I get the recurrence. I guess I'm on the right track. I thought that I could do it with what you would call it, but how did I guess they've seen it before. Oh, but what's this binary search? Basically, it adds the next number, and then it also adds. I guess this is just like the way to do a brute force in a way, but in a you know how you do a normal brute force. You know, it's just basically. That's a very clever way. I don't know that I know how to do that one though. I mean, I was trying to do it earlier, but I didn't know how to do it. Yeah, so we have this number, so then we... Okay, and then as index is equal to q, and then we basically just do one number at a time. I guess that makes sense, but I was trying to... I don't know if that makes sense to me, to be honest, but because basically now we're saying that, okay, given there's two ways to do it. We can either not use this index or we use the other one, right? So we have What am I doing? Okay, so basically now we pop this. This is no longer this is now the smallest one, and then we want to either it's either current, and then the next number is going to be minus the next number. Minus this, or but then here we put this number back in, and then we go to the next index, or we just straight up go to the next index like this, right? So that's basically what they're saying. And this is, of course, if last index plus 1 is less than n. Still not sure if I get it though. I mean, I get it, but I mean, it's actually pretty clever. I mean, I might have to. It's basically the way that we. Maybe this doesn't need to be -1 anymore because we want n iterations. Okay, that's just very wrong, but so we start at total, we go current. What am I doing wrong here? Sorry, I always subtracted it. Oh, because this doesn't include the 0, so we have to process this first. So we have to process this by either okay, so I think I try to cheat too much by the other one. So we either look at it or we just go to the next index. Yeah, something like this. Maybe not clearly. By skipping so we always need at least one number subtracted, so that's why this is a little bit awkward the way that I'm doing it. And also clearly I don't need this anymore, or when like this anyway. Because basically I'm trying to do it my own way. I mean, I did get a hint, I suppose, but yeah, let's see. So this is this using this, and then this is just not using it. But however, because this gets parsed out, we have to handle this in a little bit better way. So this should be maybe, maybe we have to kick it off in a better way. How did they kick off in a better way? Oh, I see. Because I did a min heap instead of the way that I did it is a max heap. So we want 0, 0 actually. So then we did it similar before, something like that. And then here now this is the total. So this is this plus this, and then maybe I think this is wrong, but this is the right idea. Okay, this is the heap. I guess technically this is just some nums of 0. So then now we can do the thing that we were saying. Okay. something's way off here, but how did I get the first one wrong? Okay, so this is 224. What is 224? Oh, that's the snums. Okay, so that's 6. What the hey? So I put 4, even though the expect answer is 2. Okay. Current. Because we have 5, so we have 1, 2, 3, 4, 5. Is that right? We want to. Oh, wait. No, this is right. So this is added. Oh, whoops. This is this, and then this is this. I got the signs wrong. Okay. Is that right though? Nope. I mean, it's right for the nope, not even the first two. Okay, fine. Am I off by 1? I think I'm off by 1, so that's why. Because this is already, yeah, and then in that case we said current is equal to 0. Okay, at least we got the first 2 right. 302. Wow, that is right. Okay. I'll do an explanation about this later, I suppose, but because that's what. Okay, well, I was thinking, this is pretty clever. I've never done it this way, but yeah. Yeah, I mean, what a disaster. 4/17. Right. People always want to know. I think I was trying to do something like this, but I was trying to be too. Man, I don't know how to read that. I definitely was trying to be too clever, but. Oh. I had the ideas, I suppose. But the same way. This is interesting. I thought so. This is actually the way that I was vaguely thinking of, but the way that, but definitely not like this. Also, this prefix of the k is so smart. I was thinking about doing it, but because then this the loop, the loop. Because then now this way is keeping it n square. I was thinking about that's what I was trying to do, but I just thought this would be too slow. But I guess it's n squared log n is fast enough. That's actually crazy that it is fast enough. Mostly I was trying to do this, but with this heap thing and some self-control E thing, but that's actually amazing. I'm curious how that's even fast enough, but okay. Yeah, and everyone else just did it with the. I mean, this is the same idea as before. That's what I was trying to do, but maybe not in a good way. I guess I could have done that in like 5 minutes if I was very confident about it. And this is the same way. I guess a lot of people did it that same way. and not the way, but the way that I end up cheating off pathetic dog. This is actually a good technique. This is just the depth first search. Yeah. All right, that's all I have for this one. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's contest and today's forum and all this other stuff. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.